So now that we've talked about the factory method operators and the transforming operators in the Flux class, let's turn our attention to some of the key action operators. You'll see that action operators don't modify a flux, but instead they use it for side effects. And we're going to talk specifically about two operators, doOnNext and doOnError. The doOnNext operator adds behavior that's triggered whenever a flux emits an item. And as you can see here, this behavior is passed as a consumer parameter that will automatically be called back on successful completion. In other words, if the underlying stream publisher upstream happens to invoke the onNext method and it works successfully. As you can see, this is passed as a consumer. You may recall that a consumer is a type of functional interface first introduced in Java 8. A consumer can be used as a callback, which is a very common capability in computer programming where you register something that's then later invoked under some circumstance. In this case, the successful completion of the onNext hook method. Note that the doOnNext operator in a Flux stream will actually be skipped if some type of unhandled error, namely an exception, occurs upstream. And we'll talk shortly about the doOnError operator, which can be used to handle errors rather than successful completions. The doOnNext operator returns a flux that is not modified in any way, shape, or form. In particular, the type and/or the value of its elements are not changed. The doOnNext operator is primarily used for getting visibility into a Flux stream, debugging, logging, and so on. Here's a very simple example that we'll take a closer look at when we get to the Flux EX class in the EX1 case study, where we have an from iterable factor method that takes a big fraction list, turns it into a flux, and then calls the doOnNext operator to log each of the elements that are now in that flux stream. And of course, this will succeed. If for some reason it failed, which it won't, this method would be skipped, but it will succeed. RxJava has a doOnNext method in its observable class that works in precisely the same way. So once again, we've got a big fraction list, we turn it into an observable, we use doOnNext to log each of those items. Also interestingly, Java Streams has a method called peek, and that can be used in a similar way to have some side effect or to log or print values that flow through the stream. This particular example creates a list of strings, ABC, turns them into a stream, and then uses peek to print them out before uppercasing them and collecting them into a list. Let's now turn our attention to the doOnError operator. And this operator adds a behavior that's triggered when a flux completes with an error, unlike doOnNext, which is when a flux completed successfully. Once again, a consumer parameter is passed in, and this designates the behavior to call on unsuccessful completion. And you can see what it takes here is the throwable, which is an indication of the kind of exception that occurred. doOnError returns a flux that's not modified at all, just like doOnNext. In other words, the type and/or value of its elements aren't changed in any way, shape, or form. Once again, we can use doOnError primarily for getting visibility into a Flux stream, for debugging or logging purposes. In this particular case, and we'll see this example later as well, we're going to take our list of fractions, turn it into a flux, and then we're going to divide them by 0. Well, of course, dividing anything by 0 is going to trigger the arithmetic exception, which will therefore cause the doOnError method to be called, the action operator to be called, and we're going to log the error. Notice this does not fix the error, it just logs it. We'll talk later about how to fix errors. RxJava, surprise, surprise, has a method called doOnError that works exactly the same way as the doOnError method does in the Flux case. There really isn't anything equivalent in Java Streams. So that's the end of our discussion about key action operators in the Flux class. Part 1. We'll talk about some other action operators later.